Hey AP Chemsters, this is Mrs. Vanderlei bringing you another blank wall. This is section 10.4. So this is VSEPR theory predicting molecular geometries. This is where we're like putting all that we've done so far together. All right, so how do we do this? It says draw the Lewis structure. And what I might even add before that, so let's make this, before the A, I don't know what you'd call that. But even before draw the Lewis structure, I would draw the orbital notation, because that will probably help determine how many lone pair you have. So if you need to promote, that will tell you how many lone pairs you're going to have. We got to be careful when we get down to C when we talk about that. That's because we have some double bonds coming up. So be careful, but at least it's going to help you with A, B, and D in this case. So I want to do the order notation for phosphorus. Here's my S, my P. It has 5 valence electrons. How many single electrons do we have available? I only see 3. How many do we need for chlorine? I need 5 open arrows. So I'm going to get to the D level again, and I am going to promote this down arrow and put it up here. Now how many open spots do I have? I have 5. Look at what I've drawn. Are there any lone pairs paired together? Lone pair means 2, right? Do I have any 2 electrons in the same orbital? My answer is no. So how many lone pairs will PCl5 have? 0. Okay, so this tells me that I have 5 bonding groups and 0 lone pair. What's 5 plus 0? 5. What's the basic shape for 5 electron groups? Trigonal bipyramidal. So here is my Lewis dot. So I can put a chlorine on top, chlorine on the bottom, chlorine, chlorine, chlorine. Of course, they all get these extra little dots. And if you remember how we did Lewis dot diagrams, all right, this is an exception to the octet. There's 10 around phosphorus, but chlorine has 8. If I were to count up all my electrons, phosphorus has 5 valence, each chlorine has 7, so that would be 40 electrons. I have 40 electrons here, I'm good. So it says predict the geometry of it. I really didn't even need to draw the Lewis structure once I had my bonding groups and my lone pair, but I have 5 is my total number of electron groups. I have 5 bonding groups and 0 lone pair. So here I have this. Do I need to erase anything? No, my answer is trigonal bipyramidal. Okay. Let's look at the next one. So what was my suggestion? I would draw the orbital notation for your central atom. And my central atom in the case of B is going to be iodine. Ready? So here is my S. Here's my P. Up, down, up, 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 down, down. But look at that negative. What does that mean? If it's a negative ion, I have gained an electron. And what are you going to say here? Well, holy cow, there is no places for 4 chlorines to come in. So what does that tell you? I need to open up the D so that I can have some bonding sites. So I'm going to promote this down electron, and I'm going to put it here. How many bonding sites do I now have? 1, 2. That's not enough. I need 4 if I'm looking at the subscript of chlorine. So now what? Do I have 4 open spots? The answer is yes. Now how does this help me? I have 4 bonding groups, 1, 2, 3, 4, and I have 2 lone pairs, 1, 2. So I have 2 lone pair, 4 bonding groups. So what is the total number of electron groups that I have? I believe it's 6, isn't it? So I have 6 electron groups. So what is that basic shape? Octahedral. How many do I erase? 2. And it is square planar. This is for letter B. So if I were to draw the Lewis diagram for this, I would put iodine in the middle, lone pair top and bottom. I would put chlorine kind of looking like this at 9 degrees from each other. Don't forget the lone pairs around the chlorine. And once again, because it is an ion, you have to put a bracket around it and put the charge on the out. So it's square planar. Okay. Now letter C is a little bit different. Okay. And typically your central atom is the first one written, but in this case it is not. It's going to be nitrogen. And how do we know this? Well, the AP used to have something called formal charge, where you'd have to know the formal charge, and it would tell you what the better arrangement is. They've dropped that, so we don't teach formal charge anymore. So how do I know what my central atom is? Well, if I were to look at the valence electrons, I would know that the chlorine has one bonding atom, this by itself. Nitrogen has three single electrons when I do the orbital notation, and oxygen has two. So I'm going to pick nitrogen to be my central atom. It has three bonding sites. It has the most places to bond with. So I'm going to put that there. Chlorine I can put over here. And there we go. And then oxygen, 1, 2, 3, 4, 5, 6. Well, what's going to happen here? I don't like single electrons. I can put it there. Now, does this fulfill the octet rule? Nitrogen must fulfill the octet rule because it's a 2p element. It cannot go over the octet. It doesn't ever go under it. Well, I shouldn't say it. Nitrogen's is an exception. I shouldn't say that. But it will fulfill the octet when it can. And it certainly can, because then the 2 electrons from the oxygen can swing around and go right there. So that would be the Lewis diagram for this particular molecule. And so now what? Look at your central atom. Here it is. How many bonding groups do I have? I have 2 bonding groups. How many lone pairs do I have? Well, here's my bonding. How many lone pairs do I have? 1. So what's 2 plus 1? 3. What's the basic shape for electron group 3? Remember that? 3 points of terminal plane, this trigonal planar. But how many lone pairs do I have? I have 1. So what shape is that going to be? Bent. So if I were to truly draw this as a better picture, I would probably have done this. Here's nitrogen, here's chlorine, here's oxygen, and there you go. It's a bent molecule. Okay. All right, so now what do I do? Probably letter D. I want to show you again the electron, or excuse me, the orbital notation for iodine. So here is iodine. Here's my SP. But notice I have another negative, so I'm going to put it down here. Now what are you saying? Uh-oh. There's no room. There's no bonding atom. So I'm going to introduce the D, and I'm going to promote this one. So look at the formula. It's I3. So it's like I. So if this is my central atom, I have 2 iodines, don't I? So if I have 2 iodines, I need 2 open spots. So that tells me what I'm gonna have. So if I look at my orbital notation, it tells me very clearly I have 1, 2, 3 lone pairs, or a pair means 2, and I have 2 bonding groups. So what is 3 plus 2? 5. What is 5? Trigonal bipyramidal. But how many lone pairs do I have? 3. I'm going to erase 3. And there it goes. It is linear. So how am I going to actually draw the Lewis diagram for this? Ready? Remember, I had 3 lone pairs around this iodine, and don't forget the brackets with a negative charge. Okay? All right, let's go on. representing molecular geometries on paper. So this is our way of trying to show you that it's not, splatted on the paper. How can I make a three-dimensional look to these diagrams, to the structural formulas here? So a straight line is the bond in the plane of the paper. A hatched wedge means it going behind the paper or into the page. And a solid wedge means it's coming out at me. So let's see here. You can take a look at how these are looking. So if it's linear, they're all in the same plane. If they're trigonoplanar, they're all in the same plane. If it's bent, because again, 3 points are coplanar there. But look what happens with tetrahedral. So these are in the same plane as the paper. This one's coming out at me, and this one's going into the paper. How do I know that? I have a solid wedge here coming at me, and I have a hatched wedge going into the paper. Trigonal pyramidal, same thing. This is coming out at me, and this is going into the paper. This is coming out at me, this is going into the paper. And you can see how the rest of them work. So it says, show the 3D molecule structures for each of the following. So if I have H2O, do you remember what that was? Here I have oxygen with 2 lone pair and 2 binding angles. That is bent, so it has 3 points. So if I were to do that, I have solid lines. Okay, how about PCl3? Well, that would be, well, let's see here. Phosphorus will already have 3 single bonds. I don't have to promote anything here. So I have phosphorus, chlorine, chlorine, chlorine. So is this all like splat on a piece of paper? No. This one's going to come out at me, and this is going to be wedged, okay, or hatched. So this is coming at me, this is going into the paper. How about PCl5? Well, we've done enough of those to know that it is trigonal bipyramidal. So these 3 are in the paper, same plane as paper. This is going to come at me, so I'm going to solid wedge it, and this is a hatch going into the paper. IF5, this is going to be, well, let me think, all right? I'm not sure what this is. I haven't done IF5, so I'm going to do it like this. All right, SP. Uh-oh, I have 1 bonding site right now, so I need to introduce my D. So I'm going to promote. That was lovely promotion. So what is my electron groups? I have 6 electron groups with 1 lone pair. So that's going to be square pyramidal. Okay, so if it's square pyramidal, here I have iodine, F, 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 lone pair. Very, very similar. So let's see here. I think this is going to go back. This is going to come forward. This is going to come forward. This is going to go back, and this is going to be in the same plane. Did I do it the way the book did it? La 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 la. How come I don't see the square pyramidal here? That's how I would do it. It's not on your chart. Isn't that strange? Am I done yet? No. Okay, predicting the shapes of larger molecules. What happens if I have more than 1 central atom? I have to look at the geometry of each of the interior atoms. So if I'm looking at nitrogen, I have 3 bonding groups and 1 lone pair, so it's tetrahedral, but erase the lone pair, and it's trigonal pyramidal. Okay, look at the carbon. It has 4 bonding groups, so it is tetrahedral. It has no lone pairs. Look at this carbon. It has 3 bonding groups, so no lone pairs, trigonal planar. This oxygen has 4 electron groups, 2 lone pair, and 2 bonding groups, bent. Okay. So go ahead and do, the next problem. Predict the geometry by each of methanol and sketch the molecule. Well, methanol is this. So why don't you go ahead and pause this, figure it out, and then we'll come back. Okay, so carbon has 4, 1, 2, 3, 4, no lone pair, tetrahedral. Oxygen has 2 binding pair and 2 lone pair, bent. Go ahead and do number 9. Okay, with 15 seconds to go, this carbon right here has 4 binding groups, 0 lone pair, tetrahedral, 3 binding groups, no lone pair, trigonoplanar. Oxygen has 2 binding groups, 2 lone pair, bent. That's it. Talk to you later. See you next time.